Welcome to qnawire.
Okay, so this is the free body diagram for this question. So now let's take a look at the moments about C first. The moments about C can be equal to NA, which is the normal force at point A, times the lever arm for the normal force at point A, which is 1.5 meter, and then minus the weights of the car times the lever arm for the weights, which is 0.6 meter, and then plus the horizontal force 10 kilonewton. And we know 10 kilonewton is equal to 10,000 newtons. And then multiplied by the lever arm for the 10,000 newton, which is 0.15 meter plus 0.9 meter. And we know the total moments about C should be equal to 0. Therefore, we'll have such equation here. So the positive values here means that the moments is counterclockwise, and the negative moment here means that the moments is clockwise. And we know the weight of the car can be equal to the mass of the car times the acceleration of gravity. Since in the question it was saying that the mass of the car is 6 megagrams, and 6 megagrams is equal to 6,000 kilograms. So therefore, have the weight of the car is equal to 6,000 kilograms times 9.8 meter per second square, and this is equal to 58,800 Newton. So now we can plug in these values back into the equation. So we have NA times 1.5 meter minus 58,800 Newton times 0.6 meter plus 10,000 Newton times 1.05 meter is equal to 0. So eventually have NA times 1.5 meter is equal to 24,780 Newton times meter. This will give us NA is equal to 16,520 Newton. So now we know the force along the y direction, which is the vertical direction, is equal to 0, since we assume that it's in equilibrium. So now we have such equation here for Fy, which is NB plus NA minus W is equal to 0. So we have the normal force at point B is equal to the weight of the car subtract the normal force at point A. And we know the weight of the car is 58,800 Newton, and the normal force at a point A is 16,520 Newton. So if we subtract 58,800 Newton by 16,500 Newton, 520 Newton, and this will give us the normal force at point B is equal to 42,280 Newton. So now in order to determine if the car is going to move or not, we need to compare the horizontal force, which is 10 kilonewton, with the maximum friction in this question. So we know the maximum frictional force can be equal to the friction force at point A plus the friction force at point B. And the friction force in this case, we know is the static friction. So we'll have mu s NA plus mu s NB is equal to mu s times NA plus NB. If we plug in the values, we'll have the maximum frictional force is equal to 23,520 Newton. As you can tell, the maximum frictional force is greater than 10 kilonewton. This means that the car does not move. Therefore, these are the answers for this question.